Now girls, we are on the third type of reaction, that is the reactions of acid with soluble base. We have done the reactions of acid with metals, with insoluble bases. Now here we are going to discuss the reactions of acid with soluble bases. So as you know that whenever we react acid with bases, they will give us solid water, and this type of reaction is known as neutralization reaction. Now it depends on your base whether it's a soluble one or it's a insoluble one, this base. So the first insoluble part was done in our previous video. Now here we are going to discuss the base that is a soluble one. Okay, before going for that, let me remind you something about this reaction is the metals of group 1 and group 2, when they are dissolved, they can be dissolved in water, fine, and when they are dissolved in water, they form a basic solution, and that type is known as alkali solution. So we have already discussed that whenever, if any base can be dissolved in water, it is known as alkali. Fine girls, it is known as alkali. So a base that can be dissolved in water, we have discussed about bases, we have also discussed about alkali. So whenever a base dissolves in water or it's able to dissolve in water, then that type of a base is known as alkali. Fine, we also get alkali solution or basic solution. So simply you can also rename this reaction as reaction of acid with alkali. Fine, so this soluble base is also known as alkali because it can be dissolved in water, as we have already learned that whenever a base is termed as alkali when the base has the ability to be dissolved in water. Fine, but before going for the explanation of this reaction, I am repeating what we have done in the previous video. We were reacting our acid with insoluble base, and in that part we were using copper oxide with sulfuric acid to get our copper sulfate in water. As I already have mentioned that copper sulfate is present in ionic form, it is not present in crystal form. So in order to get our salt, we have to go through certain steps. Fine, and they are also written on your book as well. Fine, bache. First thing was to react your insoluble base with the acid. Fine, you have to take a definite amount of your acid, and you have to keep on adding your insoluble base. A time will come when your acid will not be able to dissolve further base, so that is known as the saturation point. You have to wait for that point until once you get at that point, now your reaction is complete. You have to, so the first part is to wait for reaction to complete. The second part is to get away from that insoluble base that is not dissolved, because we are not going to have any kind of relation with that base. Fine, we are here to get our salt. We are not interested in our insoluble base, so we are going to filter it out to obtain our salt solution. Then we have to evaporate. The reason for evaporation is to evaporate the water that is present in your crystals. Fine, then you have to keep your heated solution for cooling for at least 24 hours or 48 hours. Fine, the reason is, if you are doing rapid cooling, you will obtain your crystal, but the crystal will be smaller in size. Fine, so in order to get big crystal, you have to wait for 24 hours or 48 hours. It depends on the nature of your crystal, or it depends on the nature of your compound. Once you are left with once you obtain your large crystal, then you have to dry them, because somehow water is present in the mixture. Fine, you have to dry them. It can be done through simply keeping your crystal in oven, or by just dapping your crystals with filter paper. Fine, and then you will be able to store your crystal, and you will be able to get further application from your crystal. So this was the summary about what we have to do while getting our salts. Sorry, but I cannot avoid the sounds in the background. Okay, fine, bache. So here the third type of reaction, simply, it's very simple. We have done so many simple reactions. Fine. अगर आप लोग इनको easy लोगे then ये भी आपके लिए easy हो जाएंगे. Fine. So think that you have deal with very simple kind of reaction, and that is absolutely right, that the reactions were very simple because you were getting just the same products, though you were using different types of reactants, but the nature of the product was the same. Fine. So just you have to generalize your reaction. The for first reaction, it was just reaction of acid with metals. You were getting your salt and hydrogen gas. The second type was reaction of your acid with a base, but the base was insoluble one. You were getting your salt and water. Fine. And then you were going for the further separation techniques in order to obtain your salt. Now here, this is the third type. It's also just the same that we were discussing in type 2, the reaction of acid with a base, but in this case we are using a base that is a soluble one. So any soluble base is also known as alkali. So here we have a very easy example. Here we are using HCl, and that is reacting with NaOH. NaOH can be dissolved in water, as you know that. It is present in its solution form. HCl is present in its solution form. You have to just simply react them. Fine. No more to do work, or no more to put on more efforts. Just you have to react them, the solution of HCl and NaOH. So you will be able to get your NaCl and water. But the same thing, your NaCl will be present in ionic form. It will not be present in solid form or crystal form. So you have to move for these steps as well. Fine. Once you are done with your reaction, then for obtaining your salt, you have to go for crystallization technique. But the thing is, how you get to know that your reaction is complete or not? In that case, in the type 2 reactions, your insoluble base remain unreacted. So you get the idea that your reaction was complete, and you just go for the filtration technique. Fine. In this type of reaction, in type 2 reactions, you were able to know whether your reaction is complete or not by just simply reaction, by reacting your insoluble base with acid. If further insoluble base was not dissolved in the acid, it means your reaction was already complete, your acid was totally used up. But in these kinds of reaction, how you're getting to know the idea of whether your reaction is complete or not? So that is typically, you can say, an experimental method in which we will be using our titration method. Titration method, I'm going to write the name here, but I'm not explaining titration method in this video. Titration method. Fine, girls. This is so practical type. It will require a practical type explanation. Titration method. So simply is that you have to remember that once you are done with your reaction and you have got the idea that your reaction is complete, then you will go for these methods. Fine. Evaporation, cooling, obtaining large crystal, and to dry them. So girls, this was all about today, and I'm going for the simple summary of what we have learned today. We have learned how to make salts. Fine. Because salts are very common, they have a diverse range of applications in our daily life. So in order to get our salt, we can perform different kind of reactions. We can react our acids. We can react our acids with metals, with base. Fine. Base can be a insoluble one, it can be a soluble one. The soluble one is also termed as alkali. Fine. So we can obtain our salt by reacting an acid with an alkali. We can obtain our salt by reacting acid with insoluble bases. We can obtain our salt by reacting acids with metals. But in the case of metals, we were obtaining our salt along with hydrogen gas. So simply we were obtaining our salt, no need to do more efforts on getting our crystals, because hydrogen gas was bubbled off, so we were just left with our crystals. We were able to get our salt in the first place. Once we are done with the reaction, we are also having our crystals as well. But in the second type of reactions, that we were reacting acids with insoluble bases or acids with soluble bases. Here the end point was a big issue. First you have to know your end point, whether your reaction is complete or not. For type B reaction, that was acid and insoluble, it was easy because you were adding more and more insoluble bases, and if the acid was unable to dissolve the further addition of base, then it means your reaction has got to its end point and your reaction is complete. Further you have to go for other separation techniques. But in this kind of reaction, you have to rely on titration method. Now what is titration method? I will be explaining it in other class. Fine. So girls, this was all for today, and you can have many type of reactions for type 3. Just take any soluble base, that is potassium hydroxide, react it with acid. You can take any acid, H2SO4, and you will be able to get your salt and water. But it doesn't end here. If you are interested in getting your crystal, and definitely because you are making salts, so you have to go for other techniques as well. Fine. And for that technique you will take the help of titration method. I'm simply telling you titration method is one of the analytical method in which we will able to get to know the quantitative studies of what we are using in our reaction. Fine. So girls, I hope it was helpful, and you must have to go through spread 11.6, and in case of any difficulty you can ask from me. Fine girls, so do your hard work and take care of yourself. Allah Hafiz.